For the group discussion. Anyone can chime in.
Have at
Awesome.
it.
So, on the precession of the stars, right? They do precess all of them, including Polaris. Now, if you were to plot that out on a trend over the course of like 100 years or so, or 150 plus, like Globe guy was saying, you would get that. You would plot a trajectory where it's going to be in a physically different spot, meaning that its ground position, that relative ground position that we use for cell nav, would correspond to a physically different location on Earth if that precession played out the way it does. But what actually happens is throughout the course of the year, like you were saying, every year the almanacs get updated. But the thing is like say for example, we take a star and it's precessing to the east by 3 arc seconds. Every year it precesses to the east by 1 arc second. So it's in like a different spot, right? But then on the 4th year, sometimes it'll go back 2 arc seconds, or it'll go back like 1 arc second, and they all have this variation, but it's all within like the same kind of window range. And they don't actually change. But the thing is they don't follow that trajectory of that trend. For example, we take a star and it's precessing to the east by 3 arc seconents. Every year it precesses to the east by 1 arc second, so it's in like a different spot, right? But then on the 4th year, 1 year, over 100 years would be 1 degree, and the Georgia Guidestones were destroyed at 42 years into their life, where there would have been about a half a degree of precession already that would have been noticeable if it were actually following that trend where it continues on the path rather than having like some sort of weird reset. And like again, if you like, I know you guys probably aren't super into conspiracies or whatnot, but the Georgia Guidestone thing's crazy, right? That would have been great evidence, and then it was destroyed like a domestic terrorist attack. There's no suspects, nobody knows a thing, and it was under 24-hour surveillance. That's a really weird, thing. And then additionally, and thank you for giving me the time to speak. I really appreciate it because there's a lot to catch up on. You guys covered a lot, so I just want to kind of run through my list here, if you don't mind. Another thing in regards to the almanac. So the position that's based on the position, like a snapshot of the sky on the vernal equinox. So it's basically taking that snapshot of the sky, and then from referencing out, they took cosines to stars and following their that cosine relationship to the ground distance. For the baseline of the triangle to follow the ground distance, as a ratio of the angle to the star. They would traverse the land and then take zenith measurements, and that was. And this was repeated several times throughout the history of the globe. The coordinate system that's in use, which is the latitude longitude system, and that system has never had to be adjusted for like ground position precession because all of the stars, that precession is like locked into some variance range that doesn't extend past. It doesn't follow that trend like you would think it would. Otherwise, they would have to change things. And then we've been using that same coordinate system since 1777. 1 second, I'm going to drink some water here. We've been using that same coordinate system since 1777 by royal decree. And, they make the annual corrections to it, like you were saying, but the ground positions do not change. And then obviously you guys are familiar with stellar aberration and Aries failure, where in 1777, using the reference point of that first cusp of Aries, they determined that there was an aberration to the tune of 20.5 arc seconds, which when you ratio that over the speed of light, you would get 30 kilometers a second. So they took that in good agreement that the reason of the precession that the reason for aberration rather was the Earth's relative motion of to the sun with respect to incoming parallel light rays from stars that are basically so far away that, they're fixed or whatever, right? So, and that would create that deviation angle because we're moving out laterally from them. And then obviously there was Aries failure, who measured the same aberration for water as he did in air, indicating that the starlight is actually coming in with a horizontal drift and the Earth is stationary. But before we get to that, I would like to talk about his apparatus and how he took his measurements, because I think it's really cool and nobody really, probably not a lot of people know about it. His telescope was a zenith mount that rotated on a spindle on a horizontal axis, so it was completely fixed and stationary, and he had a micrometer grid underneath the eyepiece, and a micrometer grid is basically little thin wires that are 1/1,000,000th of a meter, and within that grid, he would look through the telescope, and the position of the star would be three little notches off in this grid, and that would correspond. He was relating arc seconds to 1/millionth of a meter for that grid. So that's really cool because it shows the relationship between the sky and the ground and how the usefulness of the coordinate system in relation to the GPS and everything. Because actually, all units of measurements are a ratio of the graticule, which is the spherical coordinate system that's latitude and longitude. So 1/10 millionth of a terrestrial meridian is 1 meter, and a terrestrial meridian is the distance from the North Pole to the equator if it was linearized on an AE map. So 6210 miles would be the equivalent for that. So anyway, it's really interesting how all those are related. What's up? Go ahead. What's up?
We really need to land the plane.
Oh yeah, no, yeah, you're good, man. You guys are having a great build earlier, and I just wanted to add on to all of that.
Sea level, hold on. Oh my God, sea level, you always add.
He's saying all that just to say.
I know, sea level,
Right?
I know. You're gonna add something that everyone's gonna just switch over to flat Earth immediately. Just wait. Space audits, you can continue. Just.
Thank you.
We got to get to it.
Space
No,
audits.
yeah, I appreciate it. Sorry, I got a little carried away on the details.
Quick tip: use crayons and speak in very, very dumb language.
Yeah, if you need to, every once in a while, to keep their attention, shake a pair of keys.
Yeah, I can't find my damn baby keys. I lost them.
Right. All right. So yeah, I'll wrap it up. I'm almost done.
Oh, 1 second.
So yeah,
though.
I just wanted to note
that you mentioned could go either way. It's been known
I just
to go
wanted to
either
note
way.
on the
One
accuracy
can
of the position of the
determine it either
stars,
way.
and that the precession trajectory that you would think that you would expect isn't what's followed. And you could even reference back to Ptolemy with, and I know it's Ptolemy, but I like to pronounce it Ptols. But anyway, Ptolemy, you can reference his Geographia book where he made the same latitude and longitude system off of positions of the stars, and it's
Thanks
the same
for
one that
hot
we use
micing
today. So it
fucking
goes
glow
back
in
deep,
the glow
boys.
face.
Like these positions are pretty much absolute. And then you guys were talking about relative motion, which is kinematics. So you guys were talking about the movement of the stars. That's kinematics. In kinematics, relative motion is always true. So you could equally say that the precession of the stars would be due to Earth motion, or you could say that the motion is due to the sky with respect to a stationary Earth, because like I said, kinematics is there's no distinction between the two. When you get into dynamics, that's where you would be able to make definitive predictions and show the difference between reference frames, because so that one guy who said that the Earth, the lab frame, is the fixed frame in space, which I know that we're all kind of taught that the Earth is just inertial enough for all experiments to be done, in pretty much for everything except for when you're using light for measurement. There's a west to east bias drift, and they say that that's due to Earth rotation. But again, that could be due to ether wind, and we can get into that discussion, but that's a whole separate build thing.
They didn't even know where you were going. I love it.
So, Legend,
you're good.
You brought up something a second ago about his experiment. What were you asking?
He clarified it. It was what I was thinking. The experiment actually proved it. You can't be proven either way. Like,
have you guys heard of Newton's bucket?
Maybe.
Oh, so it's a really good proof that the Earth is is stationary and non-rotating, in that it because it makes a really good dynamic prediction that's never been falsified. So the prediction goes as follows: we have a stationary bucket full of water, and the prediction for the centrifugal force on the water is that it doesn't have any because it's not moving, right? Okay. When you spin the bucket of water, before we spin it, if you place an observer in the bucket, he's going to make the same prediction as well, right? His velocity is 0. So he makes the correct prediction while stationary. Now, when you spin the bucket, in the lab frame, you can tell that the bucket is spinning, and you apply the centrifugal equation, the centrifugal force equation to the bucket. You will predict that there will be a hyperbola in the water, right? Now, the lad inside of the bucket, he would register his velocity as 0. He would apply 0 for his centrifugal equation. Yeah, you can look it up. This is how it goes. So he would predict his velocity as 0, but yet there's a hyperbola in the bucket.
No.
So he makes the incorrect prediction. So using a bucket full of water,
centripetal force would be insane. Huh? The centripetal force that you're talking about. So again, when we're talking about the Earth rotating. I don't remember the exact number. Maybe someone knows it off the top of their head, but the force is so small We're talking about 15
1,037.
15 degrees. It's 15 degrees per hour. The outwards acceleration from the
We're
Earth's
talking
rotation,
about
even
a
at the
bucket
equator,
of
where
water,
the
bro.
tangential speed would be the fastest, right? That 1,000 miles per hour that always gets mentioned. I think it's only.
I'll be right back. I have to go carry groceries. I'll be right back. I apologize. I'll be right back.
Okay.
Hold that thought.
Space.
Well, then maybe
Love you,
somebody
man.
else can reply. But that acceleration is only like 0.02
I think you
meters
missed.
per second.
I think you missed one of the statements he said. Einstein said it's kinematic. You cannot
hold
tell
on.
from the Earth.
I just
that
wanted to
it's
tell
spinning.
Globy, you got muted because you were hot micing a second ago, just in case you didn't know.
Like to forget about Einstein.
Cool. All right, go ahead, Legend. Sorry, what were you saying?
Of what he said about kinematic, right? What Einstein said, you cannot prove from Earth that the Earth is spinning. Like for you to say that it's so
Not that it's not
small that we
spinning.
can't
No, no, no.
test it
Not that
is
it's not
going
spinning.
directly against the actual observations and tests that we
He's
can.
talking about our orbit around the sun, and he's saying there's no optical experiment that can confirm that. That's a very.
Not
So
what he's
you're
talking
saying that
about
I
at
could
all.
take a bucket of water and spin it, but I'm spinning it so slow that I won't see the curve in the water, but the water will stick to the edge of the bucket. Like it's illogical.
Yo, I'm
what
sorry.
you
I'm sorry
just
about
stated.
that. And I read the text message
Go
while
ahead,
they're not
Space.
even here. They're late.
No.
So anyway, you were saying the centrifugal force wouldn't be enough to bend the water.
No, that's not what I'm saying. I'm saying when the Earth is rotating itself, that force is going to be so small, where over time, sure, we have that kind of oblateness, right? That's fine because we're talking about the angular momentum of the Earth form, blah, blah, blah. We don't need to go that deep down the road. But that rotational force is so minimal that obviously gravity, 9.8 meters per second squared, 32 feet per second, that's going to overcome that by a long time. I'm sorry, Globy, you go ahead. Didn't mean to cut you off.
No, I was just going to ask Legend to define kinematic. I'll mute up and listen to his definition.
My understanding of kinematic is that it's equal, it's undeterminable, and I don't actually have a definition for it. But I've heard the term used, kinematic, meaning that it's equal on both sides.
Oh my God.
But you could tell me a definition I can use better.
If you don't mind, I got you.
I would like to know why you're invoking something that you don't understand. And yes,
I
space.
do understand it. I just don't have the means to define it for you. But space will help me.
That
in the
does.
future,
Unfortunately, that's not how that
because
works.
I'll
Legend.
be able to use that in the future. I love it.
Unfortunately, you can't invoke something and claim something and then not know what that thing is.
It.
Well,
Yes, you did.
He
I
may
did not.
he may have made a mistake, but by happenstance, he used the correct word. So for the audience, though, I think we
He's
should define it
parroting
so
his
that
flurf
everybody-
daddies is what happened
Well,
there.
that-
Space audit.
That's okay, man. Everyone does it on both sides. It's all good. So let's define it though for the audience so everybody can learn
Sure.
and have a beneficial experience. So kinematics means measurement.
This guy's still so
and it's
positive. I love it. Sorry, go
and
ahead.
it's predictions of future motion based on no forces, right? You're just observing something moving and you're plotting out its trajectory. So let's say I throw a baseball at you and you're looking at it. You're not concerned with how much force I put into it, how much torque, how far I twisted my arm back, how much friction there is or anything like that. All you're concerned about is the velocity it's coming at you and you're predicting where it's going to be over time. So that's all kinematics is. When you look at the equations that govern kinematics, it's basically just distance, time, and integrals of that. That's basically it. There's no forces involved. When you get into dynamic predictions or dynamics, that would be where you're introducing forces, where you would account for things like friction, different resistances, et cetera, right? Material properties, stuff like that.
I gave you a follow, man. I hope to see you in the future, man.
Hey, I'm sorry.
you
Did one of my
will.
mods get rid of Tristabis? Just wondering, because apparently
No, but
got removed from the live.
Jane St. Pierre is in the box.
I don't know who that is.
Why does that name sound so
Let me
familiar?
say
And
this for you.
Hasselblad, I would appreciate it if you stopped giggling while I was
hold up, Glow.
berating flat earthers.
So let me tell you this. So kinematic, as I understand it, I threw a baseball at you, but it's not moving.
Yeah. So you could say it like that's true. In kinematics, relative motion is always true. So you could say that I threw the baseball, right? But we could take a snapshot of that, make the baseball stationary. and have you come at the baseball with the same velocity that I was throwing.
Yeah, I was just looking for a video I saw once that really described it in terms Flurfs could
Oh,
understand.
here comes the ad.
Is it the one with the Mythbusters shooting the ball while they're also going 60 miles per hour?
What's up, Shane?
That is a good one.
How do I mute my phone mic? All right, hold on. Oh, I got it.
I got to go. Average. Thanks for having me up, man. Mad
Yeah,
respect.
here. All
I
right.
appreciate it. Like it was good. Globy, good to see you. See,
Absolutely.
Hassel, fucking Space. Good to meet you, man. Hope to see you in the
Good to
future.
meet you too, man.
All right,
Later,
bye,
bro.
guys.
Yo, we talking kines and dynamics in here?
Lord.
Kinematics and dynamics?
Yeah.
Little physics observations of the celestial motion?
Kinneys and
Yeah.
dynamies.
Yeah, we got a little vernacular for it. But real quick before you start, Shane, average Glober, man, thanks for having me on. I appreciate the mic space you gave me. I've had a rough landing here in TikTok, but
Meet up
you've
in
been
Discord,
very
brother.
welcoming. I appreciate it, man.
It's all good.
Is this the Shane St. Pierre of MC Tune fame?
Am I a fan of Mike? I don't know. I mean, I haven't blocked him.
You've been
Would-
on
would-
his
Would
lives
you
before,
guys
though,
say
right?
would you say that you guys are secret besties? You guys just don't want to admit it?
I say I'm overly nice to all of my enemies. So
He's your
about-
no,
That's
come
what I
on.
thought. It
He
is.
can't be your
it is him.
enemy.
well, about, I mean, like, you know, it's an enemy so much as I'll make like an awesome comment and he'll come in like the villain from a cartoon, like, ha, and make some dumb comment and then leave and then not answer any follow-ups, if that's what you mean.
We're the Globers. We have to be the actually, we have to be those guys. That's part of the role.
Well, no, there are other Globers. I'll give you an example. Daza, who will come with a scientific response and a proper, actually educated, like reciprocal guess, right? Or at least a sort of scientific-based analysis. And I'll be like, oh, that's a valid point, and then we'll have a conversation, right? That's a good Glober. That's what a Glober should do.
So we'll try to do that. We'll try to be good Globers for you.
Honestly, you guys seem pretty cool so far. That's why I hopped up. You guys seem pretty reasonable and rational. You were having a rough time with the earlier flat earthers, to be honest, but hopefully we can move it forward progressively, as my buddy said.
Yeah, sea level is a bit of a character, but he definitely adds entertainment. So I like having him around.
Nice.
Yeah, and there's certain flat earthers that we've been dealing with for years, right? That's a little echo. So we've been dealing with some of these guys. You know how it is. They come in and we're sick of explaining the same thing 1,000 times. So we might just start off a little aggressive with those guys.
Globy, that wasn't an echo. That's just sea level yelling into a terrible mic.
Is that what's happening?
That is the sound of a sea level doing that.
No,
Yeah,
I
that's
hear
terrible.
myself through sea level's mic. That's what I'm hearing.
I think he's just at work right now, so a lot of background noise and stuff getting picked up.
It's just unintelligible yelling. That's all I hear.
Well, you guys were talking about motion. Motion was a topic, right? Well, surprise, motion's our favorite topic to talk about. Have you guys heard about interferometry?
I have.
No, what's that?
Oh, I mean, no, definitely not. Sorry.
Oh, you might have. I don't know what it is. What is interferometry?
Well, when you're trying to use a precise form of measurement, right, you have a laser beam that gets diffracted and then recombined, and then you have what's called the diffraction pattern, which would be an interference pattern by which you can then gauge motion.
Gauge
Yeah.
motion.
well,
Okay.
More than just gauge. So check this out. When you take a coherent light beam, split it around a right angle to itself or in a loop, it doesn't matter. When it recombines, it'll be out of phase. And that out of phase will cause constructive and destructive interference. And the destructive interference part, the dark part is called fringes. Those fringes you can measure in a distance of the wavelength, and the distance of that fringe will be proportional to the square of the velocity that caused the fringe. So when they did, starting with Fazal, with an interferometer trying to confirm the hypothesis of Fresnel for Fresnel drag, he measured the velocity of water going with and against the translational speed of the water. So it was like, say it was moving at like 10 miles an hour or whatever. He shoots the light beam, splits in a loop to itself. When it recombines, it's out of phase 44% of the velocity retarded of the 10 miles per hour. and then also boosted going with it by 10 miles per hour. So an 88% proportional velocity ratio to the speed of the running water, and that's independent of the refraction index of the water. They already accounted for that with it. So that was like their first clue on the ratio relationship between fringes and velocity for linear motion specifically, because it's translational speed of the water, and that's where they came up with, Michelson and the boys got together in 1887 because they were going to do the same experiment but over a larger distance and in air, to measure the velocity of Earth around the sun, and using that same relationship to the someone's mic is kind of going off a little bit. If somebody can mute, I think it might be you, Globy.
I'm not even doing anything.
Weird.
There's static coming in somewhere. Maybe it's me. Sorry, I apologize. Okay, so let's see where we're at. Okay, yes. So they were using that relationship with the fringes to make the prediction for Michelson-Morley, and then following Kepler's laws of Newtonian dynamics as applied to the sky with GMM over r squared, they determined the velocity would be like 30 kilometers a second. So they mathed out what the fringe shift would be for the corresponding yellow wavelength of light, and they made the measurement, and they got 6 kilometers a second, which is, much less than 30 kilometers, and it would be a complete falsification. And you could even look up in the 1887 paper and look at their data set. Now, they did take more measurements, but the only data set that is presented to us is it's like a series of like 20 measurement or like 12 measurements over 8 days or something like that. And then, that's what's publicly presented. But it does show that they measured just over one fringe, which would have corresponded to 6 kilometers a second, 6 to 8. Because it's square, but anyway, because of the definitiveness of that, they were in a tough spot because of Aries failure, which we kind of mentioned earlier. But that fringe relationship is pretty absolute, and they all understood that. So how you could interpret that is either the Earth is moving at 6 kilometers a second because of like ether drag or something. I know, but we're talking measurement, which is kinematics, and I'm not going to present it in a way that's one-sided. So when you have the measurement, with that velocity being absolute, the only interpretation you could make is that the Earth isn't moving at 30 kilometers a second, and you could say that the Earth is moving at 30 kilometers a second, but say that there's like an ether drag effect that you can't explain, and that's why it's off, which doesn't jive well, because if you say that on Earth, then how could you say that the speed of light is constant in space? You would lose all your ability to use it as a yardstick for astronomical purposes. Or you could interpret it as the Earth being stationary with respect to a dynamic ether wind. And if you want to get into further interferometric measurements, a man named Dayton Miller continued the Michelson-Morley saga and showed that the measurements actually increase at altitude.
Audits.
Go ahead.
You gotta land the plane. This is
for
a long time.
Oh, dude, I apologize.
Just try to summarize. We've already heard of a lot of these experiments. I'm letting you go on so the audience understands, but try to land
you're good.
the plane.
You're good. I appreciate it. I just wanted to. I'll end on what was measured was a sidereal fluctuation that corresponds to a translational speed of 6 to 8 kilometers a second that fluctuates at altitude, establishing a vertical velocity gradient. And when they talk about 15 degrees per hour and thanks Bob and that kind of stuff, that would be an ether measurement with respect to a stationary Earth.
Like exclusive to us and doesn't actually work.
Space Odyssey, I have a question for you.
Yes, sir.
What's the lost physics you're investigating?
Well, I went through the history. That's really interesting. So you know Whitsitt, right?
I never heard of him.
Yeah. So I looked into relativity theory because he was, debating people, and they would just give like a cursory dismissal of, how true relativity theory is. So I looked into it to see, just how true it was and what the arguments were. And when I got to the Sagnac effect, it was one of the most fascinating things in all of history. And the history of that led me down the ether and all of that stuff, and the history of how these measurements were interpreted and all that stuff. And it, caused me to learn about interferometers and how they work and the measurements they make. And just the history of interferometry, really.
That's not lost physics, right?
I don't even believe it.
No, it's just an interpretation of it because it was shown that those measurements are absolute. It was shown in 2004 by Ruyong Wong that you can use an interferometer to measure linear motion, which is a complete falsification of relativity theory, which had to be introduced to answer Michelson-Morley.
Have you uncovered the mysteries of ether yet?
Well, I'll tell you what I've learned about it so far.
Wait. Somebody else wanted to talk. Go ahead.
No, sorry, go ahead.
I'm just challenging him because he's like up here acting like he's a
It's
real.
The
So Globus, y'all need to get that understood.
The argument is one of a lack of orbital motion, right? We started with motion. We were talking about Aries failure. We were talking about motion. We brought Michelson-Morley and interferometry specifically in the follow-up with Dayton Miller to prove the lack of measurements of Earth's orbital motion. And in fact, when you go to measure, you prove the counter, meaning as we just went over, you get a velocity gradient, meaning a uniform rotating sphere cannot be responsible for multi-levels of acceleration when you're taking those measurements. So if the Earth motion is being measured, it cannot change at the same latitude at different altitude, and we have verifiable scientific evidence, papers, and measurements that say it does. That's to put it.
We do not have any of that. There has not been any verification of any change in any rotational speeds at altitudes using interferometry. Okay, that was done one time and not been replicated.
No, so you're referring to Bob, right? And we have many, many more since then. Go ahead, bro.
Yeah, I would like to defer you to the work of Dayton Miller to start off with, right?
Dayton Miller, yes.
And then I would like to recommend to you one of the Picard interferometer experiments. I'll get the year for you here in a minute. He did one at a similar altitude to what Miller did and measured the same thing. And let's see, there was... Who else was the altitude lad? Oh yeah, Yuri Galev. Now Yuri Galev is really interesting because the way that he did his measurements was with a radio link, and he was doing one-way measurements with two separate radio wavelengths, but he was doing them in a way where they would go like at different paths rather than like taking a straight diagonal path down. It would hit like a reflector and go off at an angle, and the purpose of this was so that he could establish a differential in timing based off of how long it's propagating at that altitude. And through that, he established a ratio that the velocity increases to the square of the height above the surface of the Earth, which is what Miller measured. Which is crazy, dude. And then I can get into the hydrodynamic stuff he did, but that's a bit much.
Let's not do that. Oh my goodness. I'm not going to lie. It's impressive how you do all that with no breaths in between. That's insanity.
Well, I'm just really passionate about the history of it because when you look back on it, it's really interesting because this is independent of Earth shape, right? This could be ball or globe. You can make an ether model work on either coordinate system.
Ball or
I'm just
globe?
really passionate. Yeah, I'm sorry, a flat Earth or a globe. Thank you. You can make it work on either thing.
I don't see how it work with a globe.
Well, you would just introduce a mechanism to facilitate equidistant pressure, and it would be fine. But
they would need the.
It just. Yeah, that's what I'm saying.
Hold on,
but yeah,
I wonder if we should talk to the flat earthers.
Yeah, hold on.
Well, I am a flat earther, though.
Yeah, hold on.
I'm just not going to lie about ether or anything like that.
Talking to one.
Globy, did you want to say something?
No, I didn't.
No. Okay. Yeah. Are we past that point now? I guess.
No.
I don't make mutually exclusive claims unless they're actually mutually exclusive. So when it comes to ether, you could have it either way if the Earth turned out to be a globe.
Ether doesn't exist. So
So that's the issue. I guess I would bring up.
What's your
Proof of ether.
What's your evidence for that? Vacuum properties, number one.
No,
Electric
you
and
can't say
magnetic
what's your
permeability.
evidence for no ether. Where's the ether?
Have you heard of vacuum permeativity and permeability? Those are the physical properties of ether. There is impedance in a vacuum where there's nothing in there. There's no material matter.
Yeah, you're saying that like there has to be some type of medium for light to travel through.
Mute sea level, please.
That's the thing, though.
And not only that.
That's not what those experiments. I'm just saying that's not what those experiments confirmed, and we've repeated these experiments, and by we I mean people far more qualified than myself. I can't afford that shit. But these experiments have been repeated even in modern days, and
Absolutely.
and we don't pick up any type of ethereal drag happening.
Yeah. So they all do. Have you heard of sidereal rotation detected by interferometer. Like thanks Bob, for example, the Ginger Project, Brillet Hall, basically Nicholson, Gale, Pearson, all of these things where they say they measured Earth rotation.
Sure, but wasn't that using the Earth's orbit in their assumptions at the beginning? Because we already had confirmed the Earth is in their assumptions at the beginning. Because we already
Hard to find though,
the Earth
expensive.
When?
If you want, I have a poster version. You can buy my TikTok shop.
Someone claimed
Psychological.
measuring the divergence that the actual laser makes. Yep.
Yep. And then so throughout the day, the speed of light fluctuates and measures, plus or minus to itself. And that the difference in that, when they plot that difference, like the minimum and maximum peaks against sidereal time, it makes a sine wave. So they count that as like the angular 15 degrees between the fringes and get an actual velocity out of it. But they say that they're measuring Earth rotation with that because it matches sidereal time.
So, and just because you brought this up as the example, this is probably the one people are most familiar with, the thanks Bob moment. I don't understand how some type of ethereal drag is going to affect it when it's on the Earth. That doesn't make sense to me.
Yeah, so my hypothesis...
Picking up that 15 degrees, how would that be measuring some type of rotation from the ether?
Dude, well, 100%. Check this out. So... let's see here. My hypothesis is that there is a translation of motion from the sky that is causing that sidereal drift. And that is why on the ground, there's a vertical velocity gradient that gets lower when you get closer to the ground and higher when you get in altitude. Now,
that's just not true.
Well,
you keep saying
that's just I presented some papers for you to reference. If you could please take a look
said
at the
Caleb,
data.
yeah, I've looked at the Caleb stuff.
You've looked at Galev,
sorry. Yeah, I keep calling him. I got Caleb on my mind.
What's your issue with Galev?
Yeah, it hasn't been replicated. That's my issue with Galev.
Galev was replicating Miller's work, and that was the replication of the work, and he also replicated it with an optical interferometer, and that work was also corroborated by Hector Manera in 2004 when he left the interferometer running for 3 years straight and measured the same thing.
Dude, Dayton Miller did that 5 million times. You're like, it's never been corroborated?
Okay, one person does something. That's not the scientific method.
We just named 3.
I listed 3 people over different places on Earth. That's 3 separate data points over.
I looked into this Gallev. Let's look it up. Where's Gallev's papers? Because we'll look it up right now.
I'll send it to you. Go to ethercosmology.com.
Ethercosmology.com. This is what I'm talking about, guys. This is your science?
No, that's my website where I have the PDFs easily accessible for you to get them.
Oh, here we go.
The paper's hard to get.
All right.
Link didn't work for me when I put it in.
No, it's...
You got to put an A before the E, guys.
Did not, and it didn't work.
Yeah, just go to my Flat Earth webpage where I have some stuff because of things.
Hey, listen to me. If we're going to have a conversation, I'm happy to do that, but I'm not going to be mocked by a grown man when I'm trying to share a source with them. That's
look, space audits.
Papers you guys haven't read that we've gone through with highlights. So
space audits.
Right? You never even read it. You're like, oh, it's dumb and stupid. But I get it.
No, that's fine. The problem is with what you're saying is, do you see this behind me?
Yes.
Okay. This was a rocket sent to 300,000 feet. Now, we can go look at these papers in a second, but this behind me curves at 8 inches per mile squared about, matches perfectly to the model, which is aligned with it behind me as well.
Prove that.
The fact that you're trying to talk about ether drag and rotation and these measurements is silly to me, because literally we have video from space showing the globe. Okay. Now, this isn't NASA. So I'm sorry if you take this as being confrontational, but this isn't NASA. This is a private guy. Shut up, sea level. This is a private guy who sent a rocket, a sounding rocket, to 300,000 feet. He broke the record. Okay. At the time, this was a few years ago. Someone broke it since. This is Kip Dogudas. I always say his name wrong. Okay. This is Earth's curvature matching the expectations of Earth's curvature per the math of Earth's curvature. But you want to sit here and talk about measurements of Earth's rotation done by flat earthers.
And now that I'm actually looking further into
get
them,
it.
these don't
get it.
These don't
All
agree
right.
with each other.
Earlier, when we were discussing kinematics and dynamics, you must have missed the entire point of the conversation. Because sea level. Please do not interrupt, sir. I'm in the middle of speaking, please. Kinematics
That's just
cannot
what he
tell
does.
you. Thank you. Kinematics cannot tell you which is rotating, an ether drag or the Earth. Now, I was extremely honest with you earlier when I said it would work on either hypothesis for a globe or a flat Earth. Now, when you present to me an optical measurement, right, just perspective, right, that could be at altitude, it would look the exact same way. My hypothesis on optics is that the radius of our vision is the same as the radius of Earth. When you get into celestial navigation and old astronomy, what they'll tell you is that there's an equivalence between your dome of vision and the heavens. But trust us, it just looks that way. The heavens are flat and the Earth is curved. That's what it says.
So you have globe vision, space audits.
Yes, we all do. It's called curved visual space. There's two fields of.
Sorry, man, that's funny.
There's two fields of optics, bro. There's the visual field and the spatial field. The spatial field is Euclidean, and the deviation from that is the visual field.
Yeah, go ahead.
We see in a logarithmic scale. Now, hold on a second. Sorry. Go ahead.
You're good. Go ahead. Just if I can. So I was looking into this a little more. So these observations don't correspond with each other. They're not in agreement. So, for example, Dayton Miller's and Hector's, those are not going to be the same. So let's see. I believe the first one is going to be, this is for Hector. It says, from the previous qualitative analysis, it may be said that the solar motion consistent with our observations may be in the range 300 to 360 kilometers per second, with right ascension 170 degrees to 190 degrees, and declination between negative 45 degrees and negative 55 degrees. That's compared to Dayton Miller's 208 kilometers per second, with the right ascension of 73.5 degrees and a declination of negative 70 degrees in 33 minutes. So those don't agree with each other.
First of all, I would like to commend you. You are awesome. Thank you for looking that up. Right. So check this out, bro. You know what Hector Manera did differently? He measured the fringe differences differently, and when you square that, it gave the ratio for 300 plus kilometers a second. But the periodicity and the fluctuations is what is the important part of the replication for replicating Miller's work. But he was actually measuring the distances differently. There was also another, that's actually happened a couple of times where they've tried to interpret the distances differently so that they could get a more favorable outcome to try and, bring back the ether and keep Earth's velocity. But yeah, it's the same periodicity.
That does mean that Hector's claims are they haven't been repeated, at least not with the same answers. And I mean, that's kind of why I brought up, granted, you call me a shill if you want, because obviously you're good. I've heard Toon talk about this before, so I've looked into it just a little bit. But there are more recent experiments that basically repeat like the Michelson-Morley thing, and they don't find that ethereal drift. They use more precision. I mean, the one that he brings up specifically, I think, is like from 2008.
They all trend towards zero. So check this out. Part of Dayton Miller's work, he did 30 years of observations, and what he found is that when you use different shieldings and different mediums for the light to propagate in, that affects the magnitude of the periodicity in the reading. And something that Fresnel, part of Fresnel's hypothesis earlier from Fresnel drag, was that the relative density of ether in a translucent medium is to the square of the refractive index of that medium, and that was measured by Fazao in 1852. So mathematically, that relationship is valid. So to build off of that, and also off of Denjeminov's work, who did the most modern, accurate interferometry work, whose work I'm just now getting familiar with. But the results of his showed that doing it in a vacuum versus doing it where it's completely filled with a medium, you get different magnitudes in that fluctuation, which is going to change changing that amplitude. Is going to make it look like it's trending towards zero, but it's a function of relative ether density in the medium to like carry that fluctuation, like for that to give you that velocity boost. So that's what's going on there. So when they do modern
word salad,
please, buddy, if you don't know what an interferometer is, you're not making yourself look good by saying it's word salad. Please sit this conversation out.
I know what an interferometer is.
Hang on, give me 1 second, please.
You've got into word salad land.
Buddy, we're describing measurements.
You've had about 10
please
minutes.
Relax. Just hold on 1 second. So the different shielding properties, right, affect the ether drift. When you do it in a basement below sea level, you get less of a reading. All the modern measurements, they do them in basements, concrete walls, etc. All these things affect the magnitude of the readings, but even still, they still measure. They say that they're measuring Earth rotation, right? That same fluctuation, that's the same thing that they all are measuring. Does that make sense?
Can I propose we talk about the shape of the Earth instead
Why you
of
look so
something you
butthurt,
admit
bro?
in
That's
that
what I'm
video
saying.
You
model?
guys brought up motion. Do you ever give
So
a
space audits, you've already said that this could happen on a globe as well if there's ether drift. Okay, so let's pretend ether drift exists and they're not measuring the rotation of the Earth at these experiments.
It's real.
Okay, so you've already said that it could work on both models in your opinion. So I fail to see the importance of discussing it then.
It would be a stationary globe, right? We're talking about motion.
Well, yeah.
I'm literally showing. So we can have visual curvature. We have visual curvature that we can measure. You said this happens because our eyeballs are spherical or something. Can you describe that to us?
Can I take that one real quick?
Yes. Send it, Shane. But real quick, my boy had asked me about the velocity relationship and why there was a discrepancy. That's what I was answering. Go ahead, Shane.
Okay.
Right. So we talk about kinematics, right? And measurements. There's actually a kinematic equivalence between looking out on a flat plane and looking out on a globe. You have a geometric equivalence to get the distance to the horizon, right? For a 6-foot observer, you can do some trig. You can figure out it's 1.22 times the square root of the observer height in feet. So you get that 1.22 factor. Equivalently on a planar Earth, right? You can do Rayleigh's criterion to get the angular resolution limit for a 6-foot observer, and the diffraction limit, of course, comes out to the same 3-mile limit, and at the same limit, you would
No, it doesn't.
Using the same factor of Rayleigh's in 1.22, you get the same actual distance for a 6-foot
No, it doesn't,
observer,
Shane.
2.99. Yeah.
It does not, Shane.
Absolutely does, right?
Okay, so you can show that to us right now that the Rayleigh's criterion comes out to the same exact radius of Earth?
Absolutely, homie. Absolutely.
Okay. You take the big box, you show it to us?
Yeah, you ready?
Yep.
I can use the big box. Oh, you got it. Nice.
I'm ready.
I guess this is what you were talking about too, space audits, that their eyes see that way because that's
unfortunately Shane can't turn on his camera.
Oh, he can't turn on his camera.
All right, listen, we've never TikToked before. We're trying TikTok for the first time. So hold on, help me out. I got a camera option.
You don't have enough followers to turn on your camera.
Really? So how do I show stuff?
You won't be able to yet, but
Gotcha.
Space, if you can show it, we can give it to you.
What's going on the talk rates?
You're missing it, Piezo.
That's true.
It's been good.
I can read out
Alan, you're muted.
Right? It's the Rayleigh's criterion.
Yeah, go ahead.
It's just a wavelength, right? And it's the wavelength over the diameter. So it could choose the wavelength of
Alan's muted. He's on the phone.
666.
Oh, okay.
Right? 666 nanometers. 700
Okay, so let's start with that. Let's take it a step at a time.
2.16 millimeters. For a height of 1.8 meters, you can use that math to get the arctangent of that relationship, right? And that will give you the actual radius of Earth. It comes out to 3952 as opposed to 3959 for the geometric equivalence on a sphere.
Shane, slow down.
That was fantastic word salad, Shane.
No, it was math with figures and a result.
So let's take it step by step then. That's fine. So why did you use 666 nanometers as your wavelength?
To replicate the most realistic criterion at observer sea level with
we see red
with less. No, it's the least amount of refraction is in the red-orange wavelength, and that would inhibit an observation at sea level where the atmospheric opacity is highest. So that's why you would choose.
So we only see red.
You can also do it with a number of other different wavelengths and diameters. The whole equation comes out using just the angular resolution limit with the human eye, right? So 0.1
Shane,
degrees is what it ends up
this
being.
picture is from 300,000 feet. Why are you using red as the wavelength to justify this curvature?
Any number of tuples. The data tuples doesn't matter. You said I couldn't do it. I gave you a specific parameter. You gave me open season to choose parameters to have it equal the radius. If you use this one, it absolutely works. It works with definitely other tuples. It works with different types of optics. You have cameras with different angular resolution limits. Now, R equals D over the tangent of theta, right? With theta being the angular resolution limit, D being distance to the horizon, R being the radius of Earth. You're telling me it doesn't work. The math absolutely works. The argument should be from your position that I'm cherry picking, but go ahead.
That is the argument. So you've cherry picked 666 as your wavelength of light. And I think you did that because you didn't do it. You're parroting someone else who did it, but they did it because it backs into their number perfectly. They also used the diameter of the human eye, the pupil of the human eye, the pupil, because that's what you need to use. That's the diameter of the pupil. They used 2.155 millimeters. That's a very specific number, Shane.
Because the pupil changes.
Why did they use 2.155 millimeters when your pupil varies throughout, it closes and it opens, right?
Yep.
I think it varies somewhere between 2 and 6 millimeters.
Yep.
So why'd they choose that exact number?
Well,
hence why you can use any wavelength of light.
When you're actually trying to see further, you actually contract your eyes. So when you're at the smallest, giving it the biggest benefit of the doubt. Now, if you also want to change
hold on. Not now. Let's move on.
No, you said, why would
Is this camera squinting? Is this camera squinting?
You asked me why I use the value. I said to give it the smallest value because that's when you're seeing the furthest when you're squinting.
Okay, but I don't look at things squinting.
Well, listen, buddy.
Okay.
You said I could choose the values. If you want to change it up, we can use a diffraction limit with a wavelength
Dude,
of
Shane just fucking smoked him, dog.
5,000. You can use it, change it up to a wavelength.
The diameter is the aperture. What's the aperture of this camera? Is it 2.155 millimeters?
Well, this is actually compared with large telescopes. You got near infrared telescopes. You got thermal imaging and astronomy. The ratio remains the same, homie. Have you looked into it at all, or are you going to repeat Mike one more time?
No. See, you see this? You can't see it because it's got a green screen. This is a whole page of it's 4 pages of my math going over this observation and this claim of yours. So don't ask me if I've done things. Okay, that's why I'm asking you these questions. Okay, if you use the average wavelength of light and the average size of a human diameter of a human eye, you end up with 12,499 miles as the radius of Earth.
No, you don't. No, you don't.
Oh,
what you do there is you change the wavelength, right? Because you're changing a ratio. So you're changing 1/2 of a comparative ratio, which itself is a variable, and then you're claiming that that's a real life observation. All right.
No. So theta equals 1.22 times lambda over d. Lambda is the wavelength, d is the diameter. If you plug in the average wavelength of light there, which is 500 nanometers, and you put in the average diameter of the human eye, which is 5 millimeters, you end up with 0.006876 degrees.
Yeah, that sounds completely arbitrary to pick tuples as well.
I use the average. What you did was cherry pick exactly this number and exactly this number to try to get to the radius of Earth, as if that even means anything to begin with.
Right, but as you can pick.
But if you use the average, you get this.
Well, you can also use, for say, a large telescope, regular diffraction limit wavelength.
Isn't the radius the distance from the North Pole to the equator, though?
5,000 millimeters. That also comes out to the same ratio. In the same respect, you can use a near infrared telescope, wavelength 1861-ish. Diameter 600, so the same ratio comes out. So the same way you can change the parameters of the equation to make it have a different result is exactly works both ways, right? The point of the
you guys use this as an excuse. You guys use this as an excuse as to why we see the globe looking like a globe. That's what you just said to me.
No, we're using it as a kinematic equivalence for the limits of vision versus living on a geometric globe of a certain radius and a plane. That's what we're equating.
So when I go up when we see video from a rectilinear lens of the Earth from 300,000 feet, and it looks like a globe, and it matches the curvature rate of the globe per the globe math per 24,901 miles circumference. You're telling me that happens. This is what Space Audits just said. So let me know if you agree. You're telling me that happens because we see that way, just because of this.
No,
because
what
of
we're describing is
Rayleigh's criterion
on the ground because we're using a specific observer height of 6 feet, which is inherent in the math you said you did, right?
That again?
So if we
Nothing about 6 feet. I said nothing about 6 feet.
That's that's how we're using the math to get the actual observer limit, right? For a 6-foot observer height at sea level, that's how we end up with 3 miles would be the observer, the limit that you could see into the horizon on average, based on.
I think we might be ahead of ourselves here. What is the Rayleigh criterion?
You asking me what the Rayleigh's criterion is?
Yeah, I think maybe we jumped ahead of ourselves.
Literally the angular resolution limit, right? You got diffraction over the wavelength, the rate at which the angles subtend to come and connect into the eye to display an image. That's what the Rayleigh's criterion is. Yeah.
No, it's not.
To get the actual prescribed angle of the angle of incidence bouncing off the lens to recreate the image.
So everyone listening, so this is what happens when you ask a flat earther a question and they word salad their way out of it. Okay. So no, that's not what it is. Okay. It is it describes the maximum distance that two objects will appear to separate from each other. So it'll tell you how far away you have to be until two objects appear to converge into one object.
Yep.
That's what that does.
Yep, but when applied
to
the telescope.
So if you're looking at a car heading towards you from on the highway and it has two headlights on, how far away that car has to go until those two headlights appear to be one headlight.
Right, that's definitely true. You got the radius disk and things becoming observable between one and the other. But what we were applying it to specifically is its application in telescopes and large optical instruments, right? Which is where it actually governs the angle from which the lenses can bounce light to get the specific magnification. So that's its real astronomical practical use, right?
No, I literally asked you why the Earth looks like the Earth from space. And this is what you told me why it looks like that. Because it's not actually curving at the rate of the Earth. We just see it that way because of this. This is what you told me.
So the rate of curvature
Does anybody have that
most applicable within
Amazon
trying to confirm bottom-up obstruction, right? That's
yeah, no, I'm talking about that. You see this behind me here?
You're talking about curvature from space on a satellite, right?
No, this is a rocket. This is a rocket.
This is a rocket. You got up in there too?
This is Walter Bislin's curve calculator overlaid. It's overlaid on top of video of that rocket launch.
Well, damn, look at you go, man.
That's what we're looking at 250,000 feet. This is overlaid to show you that the rate of curvature of that video of that rocket launch matches reality.
Yeah, but we're talking about ground-based observations. I'm not saying there's a kinematic equivalence from 20,000 feet to look over to find optical declination composed with a rectangular lens, right? What I'm saying is
what did you just say?
From the ground, when you're looking
a rectangular lens.
What is a rectangular lens?
Yeah, now we're getting into Josh's wheelhouse.
That's not what I meant. The what's the one?
Rectilinear lens.
Rectilinear, I think, is what he was going for.
Thank you. But yeah, but we're talking about kinematic equivalence, which doesn't really take precedence at a ridiculous observer height. We're talking about equivalence on a geometric sphere of a certain radius versus standing on a plane.
I think we're trying to figure out whether the Earth is a globe or not, and this photo seems to show that it's a globe, and the question is why.
I'll show you the video if you like. I don't know if you've seen it. It's not just a picture. So again, this is literal video evidence of the globe. So you can try to talk about your rotation experiments all you want. The Earth's a globe, guys.
Yeah, that picture confirms it, right?
The video does. I'll show you the video again if you like. He used a rectilinear lens.
Well, I mean, so if you use a different video, I can show the same declination of a horizon. I can also show in the same frame of the lens an absolutely level horizon and also a concave horizon, right? Because that's an effect of optics at height anyway. So that would
I'm glad you brought that up.
Not inclusive either way in my mind.
I'm glad you brought that up because this video And what you just did there was do the classic Flerf deflection, which is fine. I get it.
Well, you're trying to present evidence from a certain height of curvature. I'm just saying that from the same height.
Right. So you got to just say whatever you can to deny it instead of actually looking at the evidence and then coming to your conclusion.
No,
I get it.
I'm looking at your evidence. I'm giving you props for using an overlay in the curve calculator, man. I don't know why you'd say I'm not looking at it.
Thank you. Well, you're trying to deny it before you actually look at it.
Yeah, hold on just a sec. Nah. No flyer boy on my live. Go. School is in session. Go hand out some flyers to 5th graders again, Nathan. You're not welcome here.
I love that he was just up to get kicked. That's awesome.
You are not welcome in my live if you're gonna go try to talk to 5th graders about flat Earth. What the fuck is wrong with you?
So here's the video in the beginning here, and then I cut to this one. So this is a balloon, not a rocket. This is a balloon it's called Little Piggy. Flat Earthers love to use this. As a matter of fact, there's a lot of YouTube videos that use this footage. And you can see it's slightly concave. And they use this as proof of flat Earth from however high this was. I don't even know. Probably like 80,000 feet or something like that. What they don't show you in this video, and here's all the videos on YouTube, it's 4 minutes and 30 seconds long, this video. That's it. The actual balloon flight video is no longer available, but there is a 18-minute long version, and the 18-minute long version flat earthers never show you. And this is what happens in the video. The balloon pops, and then you start to see the globe go crazy. Concaves, it convexes, it goes wonky. And that's because this balloon was using a wide-angle lens.
Oh,
this is barrel distortion. So you guys literally use wide-angle lenses to flatten the curve and then say Earth is flat, right? But my point of showing this is that if you go to this Kip Dugerdas rocket launch video that I was showing you earlier and look at it when the horizon's going up and down throughout the frame, it never changes. It doesn't go concave, it doesn't go convex, it doesn't wobble. It's always the same rate of curvature through bottom, middle, and top of the frame. And then you can overlay it with Walter Bislins, which I did here at various points of that frame, and it always lines up at that height. So it matches the globe curvature perfectly.
No
wide-angle lens, rectilinear lens matching Earth's curvature.
I did it too.
So again,
2 minutes.
you can try to obfuscate all you want. There's literal video proof of the Earth being a globe.
Awesome. So is that, hold on, is that your, before I make my counter argument, are you good? That's what you're standing on.
Yeah.
Okay, great. So I stand by my original statement that we have a radius of vision, and when you go to altitude, you're going to see things like that. Doesn't matter what kind of lens you use, it's going to be the same thing. I'm having a link sent in chat to a YouTube video of a guy who corrects rectilinear lenses, and you can see the difference over a series of different images, the difference between the two. Now, I'm claiming that's just an optical effect. You're claiming it's physical Earth curvature. How can we substantiate the difference between the two? Because I'm certainly not foolish enough to deny that you could launch a rocket to X altitude and see some stuff, right? Not gonna say that's mutually exclusive to either thing. But may I introduce to you a null hypothesis, sir, where we can deduce the actual shape of the Earth with mutually exclusive evidence via shadow sets, battle of the beams, and satellite orbits in circumpolar navigation in the north-south directions.
Audits, by the way, links don't show up in TikTok chats, so you might have to point your phone at a second screen or something.
I am curious what you mean.
Dude, yeah, my bad. Can you bring this up on the big screen for me if I type, or if I tell you a URL?
I can put you on the big screen. You can just flip the camap.
Oh,
wait, your camera. I am curious what you mean by.
So what you can actually do, tap on your camera itself, and you can flip it to the back camera on your phone.
I'm curious what you mean by correcting a rectilinear lens.
Yeah, so I myself am not a rectilinear lens optical lad. I actually don't argue optical measurements at all. But like I just have a reference to give to someone, and for just such an occasion, I actually have no idea what it's about. GL with it. So
I do know what a rectilinear lens does, right?
Yeah, it makes the light rays come in parallel or whatever, so that you don't get the curvature effect or whatever.
There's no
But
distortion. There's no
yeah,
distortion.
Does
yeah,
anyone
there's still
want
some barrel distortion
It
though.
gets
want
rid
the
of all
details on
distortion.
this gift card? I just emptied it. There's no money left, but you can have it if you'd like.
How do I?
So
Oh,
I'm
you said camera thing.
curious
All right,
on
right. So
what
camera.
would need corrected. That's a weird statement.
Well, it would just be a function of how you see that. All right. So here we go.
No, wait,
Sorry,
what
this
does
is
that
gonna look
mean?
shit.
What does that mean? A
What?
function of how you see?
Yeah, you
You
just
d-
see that way, bro. When you go
No,
to that
you
altitude
don't
based on how
see.
you see
You
normally
don't
on the
see
ground, you
through
see
a
the same
take
thing.
rectilinear
this.
lens. A rectilinear lens is not
Type
what your
this
eyes
into
are.
the
So what
chat,
does that
copy and
mean?
paste this into the chat,
Cool.
and then he
It
can
means
add that to
that
the end of the
you go to
YouTube
altitude
URL.
and
The
you'll see
youtube.com
things look a
slash this.
certain way. We
It
see in a
shouldn't block
radius of
this
vision.
URL.
It doesn't
Depending
matter.
on what,
It doesn't
but
matter what kind of
oh
lens you see.
it
It's
doesn't.
all
Face
nope. There's
audits.
still going to
So
be
if I
curvature in it.
take, oh really? Have you
Yep.
ever looked through a 400 millimeter lens?
Nope. Never once.
Okay.
Are you ready for mutually
So
exclusive evidence?
no, I'm ready to press you on this because this is what I do
Go
for a
ahead.
living.
Go
So
ahead.
you're
My
telling
answer is
me,
optics.
Yeah, it worked.
yeah.
It worked.
So
Tell him to check
you're
the chat for
telling me
Piasta,
that
please.
say a telescope is going to show you curvature where none exists.
Yep.
How?
Lens is
Globe,
curved, your eye's
globe
curved.
vision.
You're always gonna see it. Yep. Exactly
Oh,
what
really? So
Globeface said.
you're telling me that if I point a telescope at a building from several miles away, it's going to make the building curve? If it's
Not
just
not the
saying a
background.
high-rise
If you're
building.
looking out at the horizon, that's what you will see. I'm not talking about looking at a
No,
flat structure
Alan,
building.
you
tell him to
said
look at the
optics
chat.
make things curved because they're curved, right?
Mhm.
Okay, so no matter what I point those optics at, it should always
You're right.
curve it.
Yes.
Yeah.
I agree.
So like if
I
I
do.
put a fisheye lens on my camera and I point it at straight lines, that barrel distortion is always going to be there no matter what I'm pointing it
Hmm.
at. It doesn't matter if I point it at the horizon or a vertical line or a horizontal line, the barrel distortion is always going to be there. So how does a telescope do that?
The lens is curved and your eyes are curved.
Weird. So why is it I can point a telescope or even a 50 millimeter lens at a straight line and it appears to be straight? Distortion happens throughout the lens always if the lens has distortion.
What are
It
you
doesn't
comparing it to?
change based on what
Parallel
you're pointing it at.
lines converge no matter what you're using.
Are you talking about lateral image compression?
What
They
about
do.
No, I'm not talking about lateral image compression. I'm talking about lens distortion. So space audits claim here is that lenses, because they're circular, will make things look circular. Yet we know
Dude,
that
I
to
hate
be
to talk about optics
completely
for hours.
false. Like
It
you can
never
walk
ends.
outside with your phone and take a picture of your house, and all of the straight lines are going to appear to be straight for the most part. Now you can change the lens on your phone and add more distortion,
That's literally.
but if you change the lens
That's
and there's
image
distortion in
compression.
the
You
lens,
just described
that distortion is going to happen no matter what you pointed at. If you change the lens and there is no distortion, or it's pincushion distortion, that pincushion distortion or no distortion is going to happen no matter what you pointed at. So it's weird that you say, yeah, if you point it at a building, it's going to be straight. But if you point it at the horizon, all of a sudden it's going to
That's not the link
distort
I
it. Like
sent.
the lens cares what it's pointed at. This
That's
makes
actually,
absolutely no sense.
That's actually
Listen,
why I brought up this video
when
specifically.
we're talking looking out at the horizon and making an optical measurement, I'm not talking about referencing lines on a building or something, right? We're talking a radius of vision. My premise is that parallel lines converge optically, right? Train tracks, etc. The sun being 800,000
Those train tracks will
860,000. 1 second. The sun being 800,000 kilometers wide, us being in the center of it due to gravity, yet we see it as a focal point of 0.5 arc seconds angular size in the sky. So we see in curved visual space, we see in a deviation from the Euclidean geometry. This is present in all optical phenomenon. What I'm specifically talking about is how far you can see how that creates a radius of vision. When you go to altitude and look through a camera
check
lens,
that.
You're
you still
missing
have
the point, space
nope,
audits.
you're missing the
missing
point.
the point.
Hold on. You're missing the point, and you're honing in on the irrelevant
This
part.
video actually
What I'm saying
addresses the
about
concern you're bringing up.
It's irrelevant because it destroys
man,
your entire argument.
I have one last thing to say before I round off my argument, and then you could proceed with yours that isn't related. So when Globey,
it's not related, except it's the entirety of the point.
So when Globey presents the rocket, right, and he's like, we're at altitude, you still have a limit of vision. That's going to create the same effect that he's saying is presenting as globe
vision.
Yes, exactly. My premise.
I love that you've confirmed globe vision for me, because I've been trying to push this for a while. Earth is flat. We just see everything looks like a globe because globe vision.
Okay, you can go to Google and type the direct measurement of curved visual space and read that paper. It's a really interesting introduction to the subject, and then follow up on the references, and you can learn more about
Can I
curved
go
visual
stand
space.
on your railroad tracks with a lens and make the railroad tracks always straight, even if they're converging? Will the railroad tracks through that lens ever curve?
You guys ever heard of Radio Horizon, Battle of the Beams?
Hold on.
Hold on.
Yes, hold on, Shane. Hold on. We have to finish up with the optical equivalences. Yes, you can make them appear straight at certain distances, but they still converge when you
If I
when you
point that lens, that makes the railroad tracks always look straight at anything else, will it ever make something that is not curving curve?
I didn't agree that it doesn't make it converge. They still
I
converge.
said curve, not
right?
converge.
It's
curve.
Yes, it straightens them out a little bit, but they still converge.
No, it
and you
doesn't
still have
straighten them out.
And you still have a
them
limit of vision.
Yeah, so there's a limit of vision, but
then
does
what are you
it make
talking
it
about, bro?
curve? Does it make it curve? Can I have a lens that makes straight lines always appear straight and curved lines always appear curved without any distortion?
No.
Yes. Oh my God. See, you guys want to go to the word salad and use all of these words, but you don't understand simple concepts.
Word salad again.
Not Jesus Christ. Globe vision doesn't exist. The Earth's a globe.
And hold on.
If vision worked the way that he described, the sun would be the biggest object
I've been
in the
trying
sky.
to show this for a minute. Just hold on, because this addresses what you're bringing up. So first of all, this is going to just be a high altitude balloon. It's a 120 gram helium balloon, so it's rated, a 600 gram helium balloon. It's rated for about 120,000 to 140,000 feet. Okay. And what we can see, they tell us the exact camera they're using. It's the Get Up, Get 2P action camera. If we look it up, I'll do it real quick. Get Up, Get 2P. If we just look that up, we can see on their website. So obviously this is being marketed as no distortion, no fisheye. It's just going to be wide enough so we can actually see to the edges of this frame, right? We have the actual box he built around it. We can see on the ground, straight lines are remaining straight. This isn't the direct corner of the frame. Same over here with this house, that's straight. And then this is a 4.5 hour video. Obviously we're not gonna sit here for 4.5 hours and watch it.
Let's do it.
Let's just say about an hour and a half into it, we're not really seeing any curvature yet, right? We're not high enough, but that's a pretty good distance away. I think we could both agree there. I don't know the exact distance, but
there's a cloud bank
why
distorting
is it
the
not
horizon
curved
line.
there if it has something to do with the distance from the frame, or even here?
Okay.
Right? Unless we were to compress this, side to side, we're not going to see any noticeable curvature. We're not nearly high enough. By the time we get to the end of the video, though, that curve becomes really obvious. And then
this is the perfect part to interject the Blue Origin video. This is the perfect time to do that.
I've been doing it.
We're not seeing the
They're
curvature
not seeing
change.
You can take a picture of
Can they
any
not hear
straight
us?
line on anything using any lens you want and compress it, and it will
bring this
show
up.
curvature. Now, if my premise, right? Okay, well,
Incorrect. Space. That's 1,000,000% incorrect.
Okay, show me some demonstrations of that. If you can't show me a demonstration of it right now, just let me continue.
Yeah, I would love to. My camera's on right now. TikTok is glitching. I've done this 1,000,000 times on live before TikTok was taken down, and for some reason after it came back, my camera doesn't work. It's literally on right now. If you go into Photoshop and draw a slightly curved line or straight line and compress it
Put it
from
in there
left
again,
to
BS,
right, the
please.
straight line always remains
I
straight.
did.
Always.
Not-
This is like
no,
so
yo,
incredibly
wait,
simple to prove.
wait. Hold on. Are you compressing the image that you made on the computer, or are you taking a picture of that image and then compressing it
Both.
with your camera?
Both.
Okay,
Both.
because when I did that, I have videos on my YouTube channel where I did it, and it curved both of them both times. Or I'm sorry,
Oh,
it
really?
didn't.
What lens
No, it
did
doesn't.
you shoot it with?
It doesn't curve the
What
screenshot.
lens did you shoot it with?
obviously,
What
this is my
lens
phone
did you
camera.
shoot it with?
I don't remember even what
Okay,
model it was.
was it the wide angle lens? What phone do you have?
Oh,
An iPhone?
it was a phone. It would have been a Galaxy 7.
Okay, so it's likely a 24 millimeter equivalent lens, which is wide angle, which has barrel distortion, which is going to distort straight lines.
My
That's
phone
my premise.
on my Motorola does not have a wide angle. It's one of its features. And I've taken pictures of straight edges and compressed them and seen no curvature.
Nice. Do you guys want to get together and collaborate on that? Because I would love to present a series of different things because, like I said, I did it myself. I got different measurements, and it would be cool to have a collage of it. I know a guy who did one as well, so we could definitely get together and do a collage on it. Now, I would like to advance the conversation forward because we're in kind of a stalemate here. My position is that there's an optical effect happening. You guys are saying that you can use different lenses to correct for any optical effects and show the true nature of curvature. Now, we can't really reach an agreement if we don't agree on the premise, but I think we could agree on this. To continue the conversation forward, we would have to reference a different argument of mutual exclusivity between the two to draw the distinction.
We could just go outside and measure the curvature of the Earth over 1,500 feet and find out, lo and behold, hey, it's curving.
So, SpaceAudits, we have not come to a stalemate. Okay.
Oh my gosh.
You have said, "Nuh-uh, we see like a globe."
Right.
That's not a stalemate.
Right, so we're at a stalemate then. Okay.
In your mind, that's a stalemate. In reality, that's not a stalemate. You can't say, "Nuh-uh,
We don't see like
we
a globe,
see like a globe." Okay. We can take pictures of things that are curved and they're still curved. We can take pictures of things that are straight and they're still straight. Okay. Saying we go up in altitude and look at the Earth and it looks curved just because our eyeballs are round or whatever you're saying is nuts. It's not a stalemate. It's nuh-uh.
The thing in question is being used as the refutation, and I don't agree to that, and that's fine. I'm even willing to, guys, I'll take the L on this to advance the conversation forward. This is a point, but this is a potential point for you guys. If you're willing to continue the conversation, we can see which lends itself to mutually exclusive evidence. Otherwise, we can continue the actual stalemate. Exactly.
Yeah, well, he's just going to say those are optics. He's going to say those are just your eyeballs. That
is exactly what I'm going to say.
I know.
If you want to get a little history on the gratitude,
So how do
we
you
can
measure
skip past
the Earth
that.
to be flat? How do you measure the Earth to be flat then if optics make you see in a globe?
Exactly.
So there's
here we
like
go.
no way you
Here
can
we go. You ready?
Here we go.
yourself into a corner
You
where
ready?
there is no evidence.
No, we
for
found the first flat earther who has flat Earth measurements.
All right, here we go. So some people say the Earth measures flat. Some people say the Earth measures curved, right? We've all heard these things. How can we tell the difference between the two, right? My hypothesis, I wrote this in a null hypothesis form. Are you guys familiar with a null hypothesis and how this is going to play out? So the null hypothesis, we're going to start with our premise is going to be that the Earth is actually, let me give you this link real quick so you can pull it up on the big screen for me and we can scroll down because there's very important visuals to go along with this, please.
You can just flip to the back camera and show us.
It's not going to look as good though.
I mean, you can like tap on it. It's really the best we got on TikTok, unfortunately.
I think everything's.
He has to do the same thing.
All right.
Whether you do it or Average Glober does it, it's the same thing.
No worries. I had no idea how it works. Okay, no worries. Okay. So this is my premise here. The Earth is planar, and measurements of curvature are dependent on the position of celestial bodies, right?
Screen.
Because it has to measure flat or curved in reference to something else, right? And what we go in my alternative hypothesis, should I falsify my null, right, will be that the Earth is globular and measurements of curvature are independent of celestial bodies. So my man earlier referenced why don't you go out and do some measurements of the ground horizontally? I'm assuming this is going to be like geodetic surveying, right? Well, geodetic surveying
No,
is in reference,
reciprocal zenith angles, to be fair.
right, which give a radius that goes back to 3959, which goes back to the globe model, which is
RZAs.
confirmed by astrogeodetic surveying, which my premise is
Play
our
they
local
tilt away from
one
each
second,
other.
but yes, but remember I know, but remember my premise is that curvature is optical, and there's an equivalence between the radius of vision and the radius of Earth. So with
But
that
it's
said,
measurable too.
I agree. That is optically measured, but we have to decide. We're trying to find
Okay, can
mutually
you get
exclusive
to
evidence.
geodetic
Not
versus
optically
geodesy?
measured.
Yes. So for geodetic surveying, what they do is they make horizontal measurements, and then they take zenith measurements of stars, and there's a deviation from their predicted spot, and they take the difference of that and make a astrogeodetic correction, like a deflection of the vertical, essentially. And they say that they have to be in alignment with Earth's. They have to be perpendicular to Earth's gravitational potential. And that's how they justify the correction, right? Now, if that's true, right, we're still referencing the celestial bodies as to substantiate curvature. So we have yet to independently measure Earth curvature yet. Right?
Hasselblad, were you talking about reciprocal zenith angles? That's what I thought you were talking about.
Yeah, that's what we mentioned. He hasn't brought that up yet, though.
Oh yeah, I completely agree that reciprocal zenith angles are going to be your localized optical effect due to that curvature in your eye.
Not optical.
So let's start. Why don't we start with what is your proof that our eyes do that?
There's a deviation from Euclidean space, right? And that's our visual field.
Why do we get stuck on this, bro?
Right? That's
Just
why
keep
train
going.
tracks
Don't say
converge.
right. I know. What's your evidence of this? Yeah. What's your evidence of this? I don't want to hear your theory.
I got you. So on the website that I'm on right now, if you can see this picture, you see these shadows right here?
I see
What
nothing.
you need to do is turn on your camera and
You have
push
to
save.
press save.
My bad. I have to press save. That makes
Always
a lot
hit
more
save.
sense.
This whole
That
time
makes-
we didn't see anything you were showing.
Oh shoot. Okay. Sorry. Okay, let me go back.
Oh, you
Let me
were
back up.
showing
Sorry.
stuff?
Yeah, I apologize. I'm new here. Thank you.
You're going to show light shining a shadow from below onto clouds as some kind of proof of flat Earth?
Yes.
I love it.
Well,
Go
hold on.
ahead.
Globe vision,
Yeah.
level devil.
Yeah. So when you look at this shadow actually
Know how
wraps
light
around your
works,
head.
man. Come on, man. Really?
Please don't interrupt. Do you know what corpuscular and anti-corpuscular rays are?
Yes.
I've never
Heard of them. Jesus,
Okay.
man. We've been having this conversation for years. You're not saying anything we haven't heard.
Wow.
Sorry, I don't mean to ask it in like a condescending or anything like way. It's more conversationally for the audience and stuff.
It's just just get to your point
Okay.
and land the plane is the point.
Oh,
I already
gotcha.
kind of gave out our argument for this before you even started.
Yeah. Okay. My bad. So anyway, we see corpuscular and anti-corpuscular rays. They wrap around us. That's due to our dome of vision. We see in a 360-degree dome, and that also works with shadows. You can go to Taboo Conspiracy on YouTube and type shadows in his search bar, and watch the video of a shadow doing the same thing as an anti-corpuscular ray. So we have this relationship.
Where does
we
the
see
light
curved-
source have to be to create a shadow? Where's the light source in relation to the shadow?
in front of the object? Depending on where you're at, I guess.
180 degrees away.
If you
from
go
the
on top
shadow,
of the
right?
mountain, the shadow's
Sure,
not
yeah.
on
And
the
we can
clouds
determine
anymore.
determine the direction of the light by just looking at the shadow, right? The shadow will point to the light source.
Hey, real quick, can I drop for a second to let JT up? I think he has something to show that will demonstrate this.
I mean, no one wants your show ass here anyway.
Corpuscular rays from above are parallel.
Oh, why are we stopping here?
Just for reference, I can also go to Taboo Conspiracy and look at him lying about Mont Blanc from 700 miles away. I can watch him lying about the Crete Mountains during the sunset. So I can go there and watch a lot of other things where he's lying.
That's true. That's true. Fair enough. So check this out though. You can't really lie about this is just an optical effect, right? So that's the back end of it. One second. Let me go to the front. Okay, so this is you guys see this? This is the sun being blocked by a cloud, which is creating a shadow. And you see the shadow goes from convergence to divergence overhead. And then as she looks up and turns around, this is the shadow. it's after it diverges out to the like its maximum dimensions at her zenith, it starts to reconverge into the horizon, right?
Just play it.
Go ahead.
Where does the light have to be coming
have
from?
a gender?
What's that?
Where does
Play the video.
where does the light have to be coming from to create that shadow with the cloud? Does the shadow point to the light always?
Yeah.
Yeah. So if the shadow points to the light, where is the sun?
Far away from the cloud.
No, it's
Specifically,
underneath
it's
the cloud because
lower
the
than
shadow
that
is
mountain
coming
right
up,
there.
Right.
Oh, are you guys saying that this is only possible because it goes behind the Earth curve?
Because
I think your
the
intention
sun,
is to take all these arguments that we've given out against this and just go, well, this is just flat Earth proof now. Go ahead. Though.
You're about to see. Hold on a second. You're about to see the final summation of an argument done to completion. Go ahead, sir.
Great, go.
You were saying this is mutually exclusive. These shadows. So when you go, okay, cool. So when you go to the top of these shadows or mountains, you actually see the shadow on top of the clouds. This is just a perspective effect, right?
That's incorrect.
So how do we? No, it's not. We can watch a video of it on Taboo's channel.
Yeah, those are two different observations.
If you want to.
Those are two different observations. You can go show it, but those are two different observations.
Yeah. Okay, so they're always above the horizon, right? That's my premise. Shadow sets would, if the Earth was going around the curve, like you guys suggest, there would be a mutually exclusive shadow set here, and we're going to look at that now, since we're all on board with the optical equivalence.
This is like zooming in on small boats that aren't over the horizon yet, and saying that's zooming them back in from over.
So check this out.
Two different observations.
So check this out. You were asking about shadows earlier, right? On a globe, when the sun is setting behind physical Earth curvature, objects casting shadows will cast a shadow higher than the objects themselves. So what would happen with these pillars, right? They're going to cast a shadow higher than the pillar themselves. This window in the background right here. Oops, 1 second. Let me tip this over.
Back up a little bit.
Yep.
We can't see the other
This
part
window
of it.
right here is going to be higher than the window casting itself on a globe, right? This is what this is going to look like. Now, we have actual footage of someone's window not exceeding the height of the window casting it. And what happens is it raises a little bit, it stops, and then it fades out. Now, the globe geometrically makes an entirely different prediction. The shadows will be cast higher than these pillars. The window shadow will be higher than the window.
Do we have a photo of where the light source is actually coming from for that window? Or do we just have a photo of the light hitting the wall and then a claim that, hey, this is what I'm saying it is?
No, and that's a really good point. I'm gonna have to have that added. I actually just thought of that the other day.
Yeah.
I'm typing it out right now. That's a solid argument.
So what I would like you to do is show me an instance where I'm standing, I'm my regular height. You have a light lighting me. There's a wall like 50 feet behind me, and this light can be any power you want it to be, and I want you to move it away from me, but get my shadow to show up on the wall. So the light and I are the same height. You move it away from me, you get the shadow to be like my feet and everything are up on the wall.
Sorry, what do you mean? Say that again.
So in your model, the sun is always above that mountain, right? It never dips below the mountain, right? It just gets further away.
Yep.
Right? Okay. So I want you to do that with a light. Just use a light, put a light that's slightly higher than any object, and just move it away and get the shadow to go above the object.
Yeah,
that's
it
your
never
challenge.
Does.
Yeah,
no,
it never will.
That,
but we have this premise. In reality. In reality, we have a shadow of a mountain on clouds. How does that work?
Yeah,
like you can go take this picture yourself.
Oh,
yeah,
just eat on camera for us.
That's what I was talking about. When you go to the top of the mountain, you see the shadow on the top. It's perspective. Now, the reason I brought that up.
Perspective doesn't make things higher than they actually are. What are you talking about?
The same shadow that you see on the ground is on the top.
Audit, how do you know that it was the same time with the same shadow?
Oh, he's talking about...
How do you know that wasn't a time of day when the sun was above the clouds and just creating a shadow?
I see what you're saying. I don't know. I'd have to ask.
Because when you look at those videos and you pull them up, you'll see that the clouds are below the peak during those pictures, which means it's casting a shadow of the peak down on top of the clouds. Those aren't the same times. We're talking about when the clouds are above the peak and the shadow is being cast from underneath upward. They're two different scenarios.
This is what's weird about flat Earth arguments. Like you're sitting here declaratively, this is how it works. I'm about to bring this argument to completion. You guys are about to witness this. And then we ask one simple question and you're like, wait, I don't have that information. So if you're a truth seeker, isn't that information important? Wait, are these two photos taken at the same claimed time?
Can I
Very important.
get the
So
big
why are
box
you
real
making
quick?
declarative statements about it? Sorry.
Well, I hadn't thought to verify that. I assumed that they were, so that was my bad.
So I'd like to jump in here.
Know what assumptions?
So
Are you just gonna virtue jerk?
in this
Oh, hey,
picture,
JT,
we have crepuscular rays from above. They're
Crepuscular
parallel.
rays from above. Crepuscular rays from above.
You don't know what that means?
No, what are you saying?
So, crepuscular rays, when you're standing on the ground, they look like you're looking at train tracks.
Oh,
where
I
they
got you. You're
converge,
looking down.
right?
Got you. Yeah.
And this is from above.
Hold on.
This is what they look like from above. Okay. You can see the shadows from the clouds are parallel. Now, let's go to ground level. This is on a beach. These are shadows of people standing on a beach. They're parallel. How does that happen on a localized sun? Like, shouldn't they diverge?
Yeah.
You see why talking about all the stuff you wanted to talk about originally is kind of pointless when you can't explain this.
And I got one more about curvature.
What do you got? 'Cause I got one more as well.
What happened? What? Who keeps changing it? Whoever's shrinking it and making it bigger, stop that. God damn
Got it.
I got it.
So this is a picture of the Earth on film. It's big and round.
I like them round.
Argument's over.
Sorry.
I mean, all that stuff you're talking about, we've got all the evidence. You just are going to deny. Like, denying all the video, denying the ISS, denying this picture. There's all these things that you deny that are solid fucking evidence if this was a court case. You guys just don't accept things.
Well, no, we started first of all with motion, right, and then we didn't grandstand in virtue.
Yeah, I don't care about motion,
The
though.
argument was bringing up arguments in motion. We incorporated the shape when we're talking about kinematic equivalence optics.
Right, but
And
we
then
can
got
do
here.
gyroscopes and all this different stuff with motion. But we have all this other evidence that you guys want to look past.
Well, you guys said the motion could be explained on a globe as well. So we moved past that
No.
to avoid arguing about something that you agreed would work on both models.
Specific exclusivity is what we said, and if you don't remember,
This right here won't work on both
Not
models.
at all. Space Audits said that could work on a globe, implying some ether theory to it.
Right, but this right here on film doesn't work on both models.
No, it does not at all.
This is
That was
something
taken on
that
film.
we can point to and say, you can go look at this motherfucker.
Right. So may we talk about your premise for a second on these
Let's talk
satellite
about
image
the
you're presenting,
picture of
right?
the globe on film.
Right. So like you were saying, you said evidence in court, right? So evidence in court requires a chain of custody. Did you know that satellite evidence, both parties have to agree upon the
This isn't
evidence that's being
satellite
presented?
evidence. This is not satellite
This is
evidence. It was
picture on
shot by a
film.
human being
You
on a
think this
Hasselblad
is
camera.
a singular picture from a Hasselblad camera?
No, this
Yes.
is from
There were-
1972.
There were thousands, and yes, that wasn't a Hasselblad camera. And B, you're wrong about the satellites because anyone can point a antenna at a satellite like GOES and pull the raw data from the satellite itself. I'm actually working on doing that right now. So
I don't disagree.
I do have a question though. Have you ever been to the March to the Moon website?
No.
Okay. Well, I recommend checking it out. It's film scans of over 30,000 pictures from all the different missions. I think that's kind of where you should start.
yeah, what they did was they pulled all the film out of storage and cold storage, and they threw it all through a scanner to digitally archive it all. And you can see all the film rolls in order. I mean, some of the pictures are nothing. Some of them are bad. Some of them are shit because they're just snapping pictures. I don't know if you're old enough to remember film cameras or not, but yeah, you didn't know what you were taking a picture of. It was always shitty pictures, and you develop them, and you're like, half this roll is shit, right? But they're all on there, the shitty ones, the good ones, thousands of pictures on film.
Even scanned the frames that had light leak from when they loaded the back of the camera.
Nice. So, real quick, let's do what was the last thing you were talking about right before?
Are we going to deal with
the crepuscular
photos?
rays from above and how they match up with the shadows on the ground? They're all parallel, and that doesn't work on a localized sun.
Yeah, I'd have to think about.
Yeah, I have time to go to bed. Alan's gonna probably stay and kick ass. I'm gonna go to bed. Maybe someone else will stream.
Welcome to the show where you don't know if it's part of the show. Welcome to the show. If you don't know, it's part of the show. Didn't they teach you to reach for the stars while opening up the bars and keeping you chained down with mortgage bills and cars? Vaccines for your arms, kids sounding like supercharged, caffeinated hate-filled scars and rage-quit repertoires. No answers for yards, caught motion that's not even yours. Imposter truths like impeccable retards, lined up for your serving of gish galloping wars. No remedy can save the lost, in love with the yarn. I'm tired of walking into refracted shards, poor science displayed by disgusting bards. Soaked in sin with your dupe is delight in a new hand of cards. Been so long, seems like for love I'm just too hard, I'm just too hard, that's it. Welcome to the show where you don't know if it's part of the show. Welcome to the show. If you don't know, you don't know.
I'm not hearing anything.
No. Okay, cool. I didn't know. Because it kind of looked like it was going off. Let's see here.
Thank you, sir. All right, ladies.
So, no, I see what you're saying, Hasselblad. You've given me some stuff to consider and think about. I'm very
How
much
do we deal with the How do we deal with the photo of the globe that he has up?
Right. I was about to say, then now we can move on to the next topic that I brought up.
So, globe space, or what is this from again? You said
Mark 1972 Blue Marble.
Apollo 17.
The Blue Marble. Is that the one that they admit that it was
that
photoshopped?
Is not
and
the
all
one
that
was photoshopped. No.
That was in 2002 by Robert.
The one that
Simmons.
was photoshopped and cropped together has a picture of North America on it.
Yep. And that was taken by low Earth orbit satellites, which is why it was photoshopped. It was stitched together by, strips of data. So we don't have to talk about that one since you don't believe strips of data. This was taken on film, and lots of them were.
Let's talk about the unfalsifiable one.
This one was shot 18,000 miles away from Earth, approximately, give or take a few hundred miles, on a 70 millimeter camera with a 70 millimeter lens. What's really, really interesting is there's a guy on TikTok named Stingray who does 3D animations. He used to be a 3D animator for films and games.
Appeal to
And
TikTok
he asked
3D
me,
animation
"Hey,
guy?
what's the lens equivalent for that lens, and what was the distance away?" Now, given what we're told the size of the Earth is, the diameter of the Earth, and the said distance of that photo, and the equivalent lens, which is approximately a 43 millimeter lens on a 35 millimeter camera instead of a 70 millimeter on a 70 millimeter, because equivalents are measured in 35
I don't ever slow up, no I don't take shit. I got no love for the fakeness. If you wanna play tough and wanna hate this, I'll always show up. I don't ever slow up, no I don't take shit. I got no love for the fakeness. If you wanna play tough and wanna hate this, I'll always show up and make a statement. I don't ever slow up, no I don't take shit. I got no love for the fakeness. If you wanna play tough and wanna hate this, I'll always show up and make a statement.
Everything I do so instinctive and so passionate. Every word I move so descriptive like an adjective. I got a vendetta against people who patented being negative when you should be getting after it. I got facts over tracks, this and that. Spitting slow, spitting fast, I could roast, I could gas. Think I'm okay at last, but I don't know if that can erase all the past. And the pettiness, a reflection of the emptiness. Hilarious, you think you're worth my time, you're delirious. Mysterious, because you hide behind a fake exterior. Inferior, you know I'll always be a bit superior. Get off of me, this ain't no humble brag. I want you to hear words, you can say them back. I want you to feel free from the chains at last, and to believe in what you got, it was built to last, yeah. Now that I've been put through hell, I never got anyone's help. I had to do it all myself.
I don't ever slow up, no I don't take shit. I got no love for the fakeness. If you wanna play tough and wanna hate this, I'll always show up and make a statement. I don't ever slow up, no I don't take shit. I got no love for the fakeness. If you wanna play tough and wanna hate this, I'll always show up and make a statement.
Gonna learn the consequence of being incompetent. Mental health is confidence, dreams and some honestness. I'm not here to save the day, that's for you to take away. I could play a million mind games, but instead I say something not illogical, something that is topical. Rub it on and watch it go, make yourself unstoppable. Dreams are irresponsible, but they're always possible. If you just believe, you could be so remarkable.
Thoughts in my head, a collage and they spread. I'll be great one day, going off of my meds. No I'm not giving up, no I'm not giving in. I will make it to the top, taking off in the wind. I gotta make it, I'm saving every day to taste it. I'm patient, but my mind, it can hardly take it. I'm chasing a dream that I've had for several ages. A vacant, modern kingdom for the taking.
Now that I've been put through hell, I never got anyone's help. I had to do it all myself.
I don't ever slow up, no I don't take shit. I got no love for the fakeness. If you wanna play tough and wanna hate this, I'll always show up and make a statement. I don't ever slow up, no I don't take shit. I got no love for the fakeness. If you wanna play tough and wanna hate this, I'll always show up and make a statement. I don't ever slow up, no I don't take shit. I got no love for the fakeness. If you wanna play tough and wanna hate this, I'll always show up.
feel nauseous, believe me. Never had a lot of shit come easy. Had to work hard, struggle just to be me. Had to rise up just so they could see me. Did what I had to do just to feed me, and what was left over I put towards my dreaming. But the only thing in life that has meaning are the things you gotta work for, believe me. Take into your hands a plan, your own hands can land your own brand. And damn, I feel like no one takes accountability. They want the credibility, convincingly unwilling to put in the fucking hours it takes to get some power. Don't be fucking sour, take a cold shower, scream until you're louder, work until you're prouder. And fuck all the doubters, they're just fucking downers. I swear to God they all let me down. I always fought just to wear the crown. I'm pissed off at these fucking clowns who were all taught they deserve an ounce. It's only worth it if you work for it. It's only worth it if you work for it. I won't stop till they hear me now. I won't stop till I wear the crown. I'm just telling you to fight for your dreams, but it's not what it seems. Man, it's hard to be seen when everybody wants to be king. Yeah, they all wanna ring, yeah, we all wanna be free. So show me what you got, what you bring, how you fight in the ring, how you take a fucking swing. Do you got heart, are you mean? Got some scars, got some needs, are you willing to go bleed? I swear to God they all let me down. I always fought just to wear the crown. I'm pissed off at these fucking clowns who were all taught they deserve an ounce. It's only worth it if you work for it. It's only worth it if you work for it. I won't stop till they hear me now. I won't stop till I wear the crown. I swear to God they all